Hello everyone and welcome to yet another recreational programming session. In Porth, the stack-based programming language I'm developing, there's a very interesting place, and that place is located within the lexer. It implements the escaping inside of the string literals, essentially the ability to have things like /n/t inside of the string literal, right? So and /n is going to be interpreted as new line, /t is going to be interpreted as tab, and so on and so forth. You know, the classical thing that we received from C, but I'm not really sure if C invented that. I think it's been in the languages since forever, right? And all of the languages just basically copy paste that thing from each other. So as far as I know, we don't really support tabs, right? But we're going to support them in the future. So right now we support only new lines, backslashes, quotes, and single quotes. Like, we don't support everything because it's super easy to add later. It's not like something that I want to focus right now. So, but what's interesting about this place is that we implemented by searching for backslashes, and then once we found the backslash, we look at the next character after the backslash, and if that character, for instance n, we interpret it as /n. What's interesting about this specific piece of code is that it uses escaping to implement escaping. So it's some sort of like a compiler feature that perpetuates itself every time you recompile the compiler, which makes it feel like some sort of a quine, right? It literally uses the feature that it's implementing. Right. So it is a very interesting piece of code, and I from time to time get back to it just to admire it. But let's not focus on it right now. Let's put it aside. We'll get back to that a little bit later. And let's focus on something else. Yesterday, I got a bug report from Alexander. So he said that Porth doesn't work on Windows because of its new lines, right? In Unix, you have /n as a new lines, and on Windows, you have /r/n. And that kind of breaks our compiler. And in today's session, I would like to fix that and see how it goes. Right, so let's go ahead and try to reproduce that specific bug. By the way, thank you, Alexander, so much for reporting the bug. It is a very important bug. I want the compiler to be able to work on Windows, even though it does not officially work on Windows because we use a lot of like POSIX Linux syscalls, right? But in the future, I do plan to port the compiler to all of the major platforms, so to speak. So let's write hello world. Right, so let's try to reproduce the bug and write a simple hello world. We're going to include the standard library. So here is the standard library. Then we're going to introduce the entry point, and then we're going to say hello world. And let's bring it on the screen. So then I'm going to try to recompile it and run the entire thing. And as you can see, it works beautifully. So now let's convert all of the new lines in this file into the DOS new lines, which are basically Windows new lines. Right, so we need to use set buffer file encoding, and let's set it to DOS. As you can see now, they're all in DOS. I'm going to save the entire thing, and now if I try to compile this entire thing, it says words are not allowed at the top level of the program. Right, so essentially what we have in here, we have a keyword include, then we have a string literal, and after the string literal we have this invisible /r, right? It's invisible in this specific text editor. And our compiler interpreted it as a word, and no words are allowed at the top level. You can only put words inside of the procedures, or maybe inside of like constants or something else, but like at the top level it is not allowed to have that, and that's why it says this kind of error. So how our lexer works, right? So we have some sort of a source code, foo, bar, buzz, and then we have new lines, and we have several lines in here. So essentially the lexer first chops off the new line by this delimiter, removing this delimiter and putting aside the rest of the string. And then it tries to tokenize that specific string. So the way it does that, if there's any spaces in front, it just trims all of these spaces and then cuts this token until a new white space and returns this new token. Then it repeats the process until it runs out of all of the words, right? And then at the end, if we have a Windows new lines, right? So if the situation is something like this, it will think that this is just yet another word, right? It's just yet another word. So the idea I have about fixing this entire thing is essentially treat /r as a white space, right? So right now we're using a function from the standard library, str_trim left, and it basically trims exclusively white spaces, right? It's like specifically spaces, but it should be able to trim like everything. So I think it should basically use something like is_space from C. Right, if I Google it up, so it's is_space, and it treats a lot of characters as white spaces. So basically it considers white spaces as space, form feed, I have no idea what is a form feed, line feed, carriage return, by the way, carriage return is white space, horizontal tab and vertical tab. So yeah, we basically need to consider all of these things as white spaces and trim them off in this specific function. Right, so let's go ahead and do that. So instead of just comparing this entire thing to white space, let's introduce a function called question mark space. By the way, question mark in a port doesn't have any specific meaning. It's just like a regular character, and you can use this character within the names of the variables, procedures, and stuff like that. And the same thing is in port. And as far as I know, in port there is a convention. If you have some sort of a predicate, usually started with a question mark, but I'm not sure. I never really programmed in port. I only heard about it. So, but we're going to use this convention in port anyway. So let's introduce procedure. It's called space. It's going to accept the code of the character, and it will return Boolean indicating whether it's a white space or not. Though I don't really plan to... Well, I think it would be easier to actually use conditions in here, yeah. So I thought that I'm going to make it inline, but then I realized that the easiest way to implement this entire thing is to use like ifs, and ifs are not supported in inline procedures right now. They're going to be in the future. So anyway, I'm going to duplicate this thing, and I'm going to just basically compare this entire thing to space. And if it's true, I'm going to return true. Right, essentially. Then otherwise, if this entire thing is new line, I'm going to also return true. And otherwise, we're always returning false. So as far as I know, we're not going to have exactly the Boolean. I think this is not going to compile because we have some stuff on this stack. Yeah, there we go. So we have this integer, right? So essentially what we need to do, we need to swap and drop to get rid of the character and leave only the booleans. And the reason why I implemented it like that is that because in the future it will be super easy to add more characters in here, right? You just copy paste this line and you get more characters, which is rather convenient. And I could have just used something like or between all of these things, but or in port is not short-circuited, so you have to use if you want some sort of a short-circuiting. All right, so let's try to recompile the compiler, and everything seems to be fine, hopefully. Well, it's taking some time because it's NASM. We can always switch to FASM, FASM Linux x86-64, right, there we go. So it's a little bit faster because it's using NASM. Yep, there we go, cool. So, and let's now add the /r to interpret this thing as a white space. And it's not going to work because we don't support. So there is unknown escape character. /r is an unknown escape character. So let's go back to that place that, you know, handles the escape characters, and let's just add you know, /r in there. We're gonna make it by analogy, right? So we can even copy paste this entire piece of code. Right, and something like this. Let's connect all of that together. If we encounter error, I'm sorry, my Russian brain thinks that I speak in Russian. So we're gonna actually interpret it as /r. But what's interesting about this implementation is that it's not gonna compile. Right, so let's actually comment it out like in space specifically. Right, you just can't implement R in terms of itself, because compiler right now, the current version of the compiler that we have does not support /r. So in the current version of the compiler, you can't implement /r as /r. Even though you can do that with n, you can't do that with r. So how do you make this feature to perpetuate itself? Well, to do that, you have to actually implement it without using that feature first. So let's take a look at the ASCII table. And what's the code of /r? It's 13, right? So instead of like using this thing, let's just put 13 in here, and that will compile. And now we have a new version of the compiler where you have support for /r, and now you can implement /r in terms of /r. So to implement sort of self-perpetuating feature, you have to first bootstrap it by implementing it without using it, and then you can use it in the next versions of the compiler. So what's interesting in here is that every time I recompile a compiler, I get the new version of the compiler, right? So this is so fascinating, isn't it? Like, it's so cool. And it's like, it's really worth implementing like your own self-hosted compiler for the moments like this, because it's just give you insight, like a deeper insight into how like programming works in general. It's very interesting. Really recommend. So, and now we should be able to use this kind of thing in here, right? So now /r is interpreted as a white space. There we go. So, and can we now compile the hello world? We cannot. And something is like really corrupted in here. So, because it doesn't even produce like a proper error message. So let's actually take a look at this thing. Where do we use this stuff? I'm pretty sure we use that in here. In procedure definition. Okay, so we have a known type and a known keyword. So something corrupted in one of these two places, but I don't really know which one. Right, so let's actually put 1 in here and 2 in here, and that way we will kind of know where roughly it is corrupted. Hopefully, I don't know. It's kind of strange. The port is very unsafe language, so you can get shit like that. So let's recompile the entire thing. Everything seems to be working, so let's kind of do that a couple of times. And if I try to compile it like this, in procedure definition 1, okay, so that means it is located in unknown type. This is really strange. Like, it's capable of rendering this, but not any of this. Wait a second, do we have /r in the name of the type? And it's a carriage return, so... Oh, wait a second, is that like... Yeah, we're trying to print... We printed the first thing in here... Wait. This is so cool. We printed the first thing in here, then there was a carriage return in here, and it went back, and it like this thing overrode the other thing. Does it work in any other terminals? This is actually very interesting. Wait a second. So that's really sus. Hello, port. It's exactly the case. Holy shit, look at that. Yeah, okay, I see. So this is actually very bad. Right, so if you have some sort of like a special characters in the names, they can completely corrupt the compiler output, making it undebuggable. So I suppose if we print anything that's coming from the source code, from the user input, we have to escape that. Right, so we have to escape that, but it's kind of outside of the scope of what I'm doing right now, so I'm going to put it to do in here. Everything that's coming from the user input, aka source code, must be escaped before printed on the screen. Right, so this is actually quite important. Otherwise, if the name of the type in this specific case contains any special characters like /r, for example, the entire diagnostic is gonna be corrupted, rendering it useless. There we go. So this is very important, so I wanted to like put it to do in here. Yeah, okay, so we have what to do. So essentially now we have a very interesting situation, and that situation is like unknown type in procedure definition. And let me see. So where's the hello world? Here it is. I'm not really sure where do we get that situation, but it doesn't really matter because I think I know what causes this entire stuff. Let's take a look at the lexer next token, right? So this is where we get the next token. And I think we chop the tokens specifically by this space. Yeah, there we go. So here it is. Yeah, as I already said, we just chop it until we see a space, but we have to use the sort of like the same function to chop things around. Unfortunately, str chop by delimiter accepts specific character. It cannot accept several characters. But recently we implemented function pointers, right? So I think so the VOD is already on YouTube. If you're interested in how we implemented all of that, I recommend to just check Tsodin Daily. So here is Tsodin Daily. Thank you so much, YouTube, for recommending this entire thing. And here is the stream where we implemented function pointers in Porth. I'm going to put that in the description, right? Function pointers in Porth. There we go. So I'm going to put it in here. So, and now we can implement a version of str chop by delimiter that accepts a predicate instead of specific character. So let's actually go ahead and do that. I'm going to go into the std Porth, str chop by delimiter, right? And let's literally copy paste this entire thing for now and call this thing chop by predicate, right? We're chopping by the predicate. And instead of the delimiter, we're going to take the predicate, which is address. Address is a special type that indicates the pointer to the function, right? So this is a predicate. We're saving the predicate delimiter specifically on the stack. So let's rename this entire thing. So predicate, the size of address, and we're saving it in here. And we have to use something like this. Cool. So now, when we are about to chop by a delimiter, we should not compare to the delimiter. We should actually call the predicate, right? So let's take the predicate, let's read it as an address, and let's call it. So the implementation of the function pointer is so you cannot just call whatever you have on the stack. You have to call it like something. Right. So essentially, you need to provide a function that will provide you the signature that's going to be used for type checking. Right. So we're going to call it like space. So it doesn't mean it's going to call space. It's going to just use the signature of space to type check the procedure that we're calling. Like that. It's a small hack because I want you to keep implementation as simple. In the future, it's going to change and it's going to be more intuitive. But for now, it is like that. Right. So essentially we take the predicate. So here is the data on the stack. We put the predicate, we take its address, and we're calling it as a space, and it will perform the call, hopefully. So let me try to compile the entire thing and see if I didn't introduce any errors. Everything seems to be compiling, which is nice. So, and now in here, what I have to do, I have to use space, right? So this is a predicate. I don't really know why I have these comments. They're not really useful for anything, right? So I have to put space in here, but if you do it like that, it will just call this space. So to take the address of the space, we have a special keyword that just takes address of the space. Okay, so yeah, well, let's actually try to. I have to call it predicate. Yeah, chop by predicate. There we go, everything seems to be working, and now let's actually compile that a couple of times. Integers are not allowed at the top level of the... Excuse me, what are you talking about? Integers are not allowed at the top level. Did I... I'm not sure what the hell is going on. Wait a second. Std Porth predicate. We have to chop it when it's not. Oh, okay. So essentially, here's the loop. We iterate through the characters while the iterator is less than the size of the string, and while it is not the separator, right? So I have to put not in here. All right, so, and let's actually fix that and recompile, but I can't recompile the compiler because it just got busted. So this is the beauty of self-hosted, compiler implementation, right? So if you made a mistake, you just busted your compiler and that's it. So you have to start over. You have to bootstrap it. So luckily I have a folder with bootstrap compilers with like, not broken version. If I try to compile it, I won't be able to do that because that version of the compiler does not support /r. So what I have to do, I have to comment it. And in this specific case, I have to implement it without using that feature yet again. And now it should work. I can now switch to the latest version of the compiler, right? So this is going to be like this. And let's implement everything back. All right, so and in std, we're going to do something like this. And let's recompile a couple of times just to make sure that everything works. And there you go. So yeah. That's the beauty of self-hosted compiler. Okay, so now let's try to run hello. And I'm in the wrong folder, of course. So everything seems to be compiling, but if we try to run that hello, it is running. Would you look at that? So it says hello world, and if I take a look at the hello world file, it uses the Windows new lines, right? So we just implemented the support for Windows new lines in port, even though it does not really officially support Windows, but I mean, Windows new lines have nothing to do with the Windows API. So yeah, and this is how essentially you implement self-perpetuating feature. So it's really interesting. All right, that's it for today. Thanks everyone who's watching me. I really appreciate that. And I see you on the next recreational programming session. Love you.